All right, so are you ready to dive deep into some research papers today?
Always ready.
Okay, great. Well, today we're going to be looking at deep reinforcement learning, or DRL, and how it's being used to improve cloud computing.
Sounds pretty complex.
It is, but hopefully by the end of this deep dive, we'll be able to explain it to you in a way that's easy to understand.
Yeah, and make it relevant to your work.
Right. So we've got a stack of research papers here, and they all focus on using DRL to optimize the way that cloud resources are managed. Specifically, they look at how DRL can help schedule tasks more efficiently and allocate resources like CPU and memory in a way that saves money and energy.
Right, because cloud computing is all about using a network of servers to store and process data instead of having to do it on your own local machine.
Exactly. And it's become so essential for businesses and individuals alike. But as more and more people rely on the cloud, the demand for resources just keeps growing and growing.
Which means that efficiently managing those resources is becoming more and more critical.
And that's where DRL comes in. It has the potential to revolutionize the way we handle those complex tasks and make the cloud even more powerful and accessible than it is today.
So are you ready to get started?
Absolutely. Let's dive in.
Okay, so first let's talk about the problem that DRL is trying to solve. Imagine you're dealing with tons of tasks, all coming in at different times, with different requirements and different deadlines. And you have to figure out how to allocate your limited cloud resources to make sure all those tasks are completed as efficiently as possible.
Yeah, that sounds like a logistical nightmare.
It is, and traditional methods of managing cloud resources, they often struggle to keep up with the constantly changing demands of the cloud.
This paper actually points out that those traditional methods, they were designed for a time when things were much more predictable. But the cloud is anything but predictable.
Right, it's like trying to direct traffic in a city where the streets are constantly changing.
So what kind of traditional methods are we talking about here?
Well, you've got things like round-robin scheduling, where tasks are assigned to resources in a fixed order, kind of like a factory assembly line.
Okay, so that might work if all of the tasks are the same.
But in the real world, they're not.
Right, and then there's the min-min algorithm, which tries to prioritize the quickest tasks first.
But that doesn't always lead to the most efficient use of resources, especially when you've got a mix of short and long tasks.
So we need a more intelligent approach.
Exactly, and that's where DRL comes in.
So DRL is not just about assigning tasks.
No, it's about making the cloud learn how to use its resources most effectively.
So it's like teaching the cloud to think for itself.
Exactly, and to constantly adapt to the changing conditions.
And it's doing that by using reinforcement learning.
Right, so let's break down what that means. Imagine you have an agent, which in this case is our DRL system, and it's interacting with an environment, which is our cloud environment.
Okay, so the DRL system is like a little robot running around in the cloud.
Sort of the agent takes actions, like assigning a task to a particular server, and then it observes the consequences of those actions.
So if the task is completed quickly and efficiently,
The agent gets a reward.
but if it slows things down or causes problems,
It gets penalized.
Huh.
And over time, the agent learns which actions lead to the best outcomes.
So it's like training a dog with treats and scolding.
Exactly.
Yeah.
The agent learns through trial and error. But what makes DRL really powerful is that it uses deep neural networks to learn.
Okay, now we're getting into the technical stuff.
Don't worry, I'll keep it simple.
Yeah.
So a deep neural network is basically a computer system that's modeled after the human brain.
Okay, I've heard of those. They're used in a lot of AI applications.
Right, and they're great at finding patterns in complex data.
So in the case of DRL,
A deep neural network is analyzing all the data generated by the cloud environment, like the incoming tasks, the available resources, the current workloads.
and using that data to make decisions about how to best manage everything.
Exactly, it's constantly learning and adapting.
So it's not just following a set of pre-programmed rules.
No, it's actually learning from experience.
Yeah.
And figuring out the most efficient way to do things.
That's pretty amazing.
It is. And this is where things start to get really interesting. Because in order to make all this work, we need to model the cloud environment in a way that the DRL system can understand,
So we need to translate the complexities of the cloud.
into a language that the DRL system can speak.
Exactly, and that's where Markov decision processes, or MDPs, come in.
Ah, yes. MDP is the cornerstone of reinforcement learning.
Can you explain that in a way that even I can understand?
Of course. So an MDP is basically a way of representing a decision-making problem, where the outcome of each decision depends only on the current state.
Okay, so it doesn't matter how we got to this point.
Right, only the current situation matters.
Yeah.
So imagine you're playing a game of chess. Your next move depends on the current position of the pieces on the board, not on all the moves that led up to that point.
Okay, I'm starting to get it.
Good. So in the context of cloud computing, we can model the task scheduling and resource allocation problem as an MTP,
So the DRL agent is essentially playing a game,
where the goal is to maximize the efficiency of the cloud,
and it's making decisions based on the current state of the game.
which is the current state of the cloud environment.
And each decision it makes leads to a new state of the game.
Right. And the agent gets rewards or penalties based on how well it's doing.
So it's constantly learning and improving its strategy.
Exactly. And this is how DRL is able to optimize the way that tasks are scheduled and resources are allocated in the cloud.
This is all starting to make a lot more sense now.
Great. So now that we understand the basic principles of DRL, let's talk about how it's actually being applied in the real world.
Yeah, I'm curious to hear about some specific examples.
Well, this paper highlights a number of different ways that DRL is being used to address various challenges in cloud computing.
Like what, for instance?
Well, for example, DRL can be used to optimize the placement of tasks on different servers.
So making sure that the most demanding tasks are running on the most powerful machines.
Exactly. And it can also be used to dynamically scale resources up or down.
So if there's a sudden surge in demand,
The DRL system can automatically allocate more resources to handle it.
and when the demand goes down,
It can scale things back down to save energy and money.
so it's like having a super smart autopilot for the cloud.
That's a great analogy.
Yeah.
It's constantly monitoring the situation and making adjustments to ensure that everything is running smoothly and efficiently.
This is really impressive stuff.
It is, and we're only just scratching the surface of what DRL can do.
So where do we go from here?
Well, next we'll delve into the different types of DRL algorithms and see how they're being used to tackle specific challenges in cloud computing.
Okay, I'm ready to dive even deeper.
Great, then let's continue our exploration.
So we've got our DRL agent ready and waiting to learn all about the cloud, but how does it actually learn? What are these DRL algorithms?
Well, this paper does a really good job of outlining the main categories, the main types of DRL algorithms that are being used for cloud computing right now.
Okay, cool. So what are the categories?
So we can think of them in three main groups: value-based algorithms, policy-based, and then the really interesting one, multi-agent DRL.
Okay, so much to unpack there. Let's start with value-based algorithms. What's the idea behind those?
So imagine you're playing a game of chess. Every move that you make has a consequence. Some are good, some are bad. Value-based algorithms are all about trying to estimate the value of each of those potential actions that you could take.
Okay, so is that like looking ahead and trying to figure out what the best move would be based on what might happen next?
Yeah, exactly. And one of the most well-known value-based algorithms is called DQN, which stands for Deep Q Network.
Okay, and what is it doing? Is it trying to figure out which scheduling decision is going to lead to the best outcome overall?
Yeah, and that Q actually stands for quality. So it's trying to figure out the quality of each action that it could possibly take.
Interesting. But I'm guessing it's not perfect, right? There must be some limitations with that.
Well, yeah, nothing's perfect. And one of the limitations of that original DQN was that sometimes it would overestimate the value of certain actions.
So it might think a move is really good when actually it's going to lead to a bad outcome.
Exactly. And that would obviously lead to some not so great decisions.
So how do you fix that?
Well, researchers are clever,
Mm-hmm.
and they came up with variations of this algorithm, like double DQN, which uses a slightly more sophisticated way to estimate those action values. And that helps reduce those overestimations.
Okay, so double checking its work, essentially.
Yeah, exactly. And there's even another one called dueling DQN. And that separates the value of just being in a particular state from the value of taking a particular action from that state.
No, that's interesting. Does that help it learn faster or more efficiently?
Yeah, it can,
Huh.
especially when dealing with those complex cloud environments.
So lots of different approaches even within that value-based category?
Oh, yeah, there's a lot of research happening in this area.
Okay, well, let's move on then to policy-based algorithms. How do those work?
So policy-based algorithms, they take a more direct approach, I would say.
Okay.
So instead of just trying to figure out the value of each action in isolation, it tries to learn the best overall strategy or policy for making good decisions across lots of different situations.
So it's more about like learning the rules of the game rather than just memorizing good moves.
Yeah, that's a great way to think about it.
Okay, so what are some examples of these policy-based algorithms?
Well, one of the most popular ones is called PPO, which stands for Proximal Policy Optimization.
Catchy name.
Yeah, well, they all have these acronyms. And what's cool about PPO is that it's known for being very stable.
Okay, so Less likely to make those really bad decisions.
Yeah, exactly.
Yeah.
They make small incremental changes to the policy to try and improve it.
Okay, I like that approach. Slow and steady wins the race.
Exactly.
Yeah.
Especially when you're dealing with something as critical as cloud computing. You don't want to be making huge, drastic changes that could potentially disrupt everything.
Right. You don't want to break the internet.
No, definitely not. And then there are other policy-based algorithms as well, like DDPG and TD3, each with their own little strengths and weaknesses.
So it's like having a toolbox full of different tools for different jobs.
Yeah, and you choose the right tool for the job.
Okay, well, that brings us to the third category, multi-agent DRL or MED-DRL.
This one is really exciting because it involves multiple DRL agents working together.
Okay, so now instead of one agent trying to manage everything,
You've got a whole team of them.
working together.
Right. Each one might be responsible for a different part of the cloud environment.
Okay, so kind of like specialists, each focusing on their own area of expertise.
Yeah, exactly.
Yeah.
And the cool thing is that they can either cooperate with each other or compete against each other.
Oh, that's interesting. So they can learn from each other's successes and failures.
Exactly. And that can actually lead to some really creative and innovative solutions.
So it's like having a team of scientists working together to solve a complex problem.
Yeah. And just like in the real world, when you have a team of experts working together, you can often achieve much better results than if you just had one person trying to do everything.
I like that analogy. Teamwork makes the dream work.
Exactly.
Mm-hmm.
And this is where the field of DRL is really starting to push the boundaries.
So much potential.
Yeah, absolutely. But with all this potential also comes some challenges, right?
Of course, nothing's perfect. What are some of the limitations of DRL?
Well, one of the biggest challenges is just dealing with the dynamic and unpredictable nature of cloud workloads.
Right, things are constantly changing in the cloud.
Exactly. In DRL systems, they need a lot of data to learn effectively. So if the patterns they're trained on are always shifting, it can be hard for them to keep up and make the best decisions.
So it's like trying to predict the weather?
Yeah, kind of. The weather is always changing, and sometimes it's just impossible to predict accurately.
Exactly. And another challenge is scalability, right?
Yeah, as cloud environments get larger and more complex, the number of possible actions and states just explodes.
So the DRL agent has to sift through all of that.
To try and find the best solution.
It's like trying to find a needle in a haystack that keeps getting bigger.
A very large haystack.
Okay, well, I'm sure researchers are working hard to overcome those challenges.
Oh, yeah, they are. And there's some really promising approaches being developed.
Like what?
Well, one approach is to combine DRL with other optimization techniques.
So not just relying on DRL alone.
Right, you might use a simpler algorithm to get a basic solution, and then use DRL to fine-tune it based on real-time feedback.
Okay, so like having a rough draft and then having an expert come in and polish it up.
Exactly. And that can often lead to faster and better results.
Okay, and what about quantum reinforcement learning? Is that something we need to be paying attention to?
It's definitely something to keep an eye on.
Okay, so is that actually a real thing or is it science fiction?
It's becoming more real every day.
Okay, so how does it work?
Well, it uses the power of quantum computers, which are able to process information in a completely different way than classical computers.
Okay, I know it's a lot of physics, but can you break it down for me?
So basically, quantum computers can explore many possible solutions simultaneously, which can speed up the learning process for DRL agents significantly.
Okay, so it's like it's able to analyze every possible move in a chess game all at once.
Yeah, that's the idea.
Huh.
And that could be a game changer for dealing with the scalability problems we were talking about earlier.
That's pretty incredible. It sounds like quantum computing could really unlock the full potential of DRL.
It certainly has the potential. And as quantum computing technology continues to advance, we can expect to see even more exciting developments in this area.
Okay, well, all of this sounds very promising.
It is, but let's not forget that we're still in the early stages.
Right, but it's moving fast.
Yeah, things are developing very quickly in this field.
Okay, well, so far we've mainly been talking about the theory behind DRL.
Yeah, the nuts and bolts.
But I'm curious to see how all of this is being applied in the real world.
Okay, well, this paper actually provides a lot of great examples of how DRL is already being used to solve real-world problems in cloud computing.
Okay, great. So let's hear about some of those examples. So we've talked a lot about the potential of DRL and some of the challenges.
Yeah, really amazing stuff.
But where do we go from here? What's next for DRL in the cloud? What's on the horizon?
I think one of the most exciting areas is how we can start to combine DRL with other new technologies.
So kind of like integrating it with other cutting-edge tools.
Exactly.
Yeah.
Like imagine DRL working together with digital twin technology.
Okay, I've heard of digital twins, but remind me what they are again.
So a digital twin is basically a virtual copy of a real system. So in this case, it would be like a virtual model of the entire cloud environment.
Okay, so kind of like a simulation of the cloud.
Yeah,
Yeah.
exactly. And we can use that simulation to train our DRL agents,
Oh, that's interesting. So instead of just letting them loose in the real cloud and hoping for the best,
which could be a little bit risky.
to say the least, we can let them learn and experiment in this safe virtual environment.
Yeah, exactly. It's like a playground for DRL agents.
I like that. Okay, and why is that so beneficial?
Well, for one thing, it allows the agent to try out different strategies without any real-world consequences.
Okay, so it can make mistakes and learn from them without causing any damage.
Right. And as the digital twin gets better and better at mimicking the real cloud, the DRL agent becomes more and more prepared to handle real-world challenges.
That makes sense. So it's like training a pilot in a flight simulator before they actually fly a real plane.
Exactly, you got it.
Okay.
So that's one really exciting area where DRL is headed.
Okay, cool. What else?
Another area that's getting a lot of attention is using DRL to manage multi-cloud environments.
Okay, so what does that mean?
So a lot of companies these days, they're using services from multiple different cloud providers.
Okay, so instead of just sticking with one, they're using like AWS, Azure, Google Cloud all at the same time.
Right. And that can have a lot of advantages like cost savings and redundancy,
Yeah.
but it also makes things a lot more complex to manage.
Yeah, trying to keep track of all those different cloud services and make sure they're all working together smoothly.
Yeah, it's a big challenge. And that's where DRL can really shine.
So how can it help?
Well, imagine a DRL agent that can intelligently orchestrate workloads across all of those different cloud providers.
So it's like having a conductor leading an orchestra of cloud services.
Yeah, that's a great way to think about it. And as more and more companies adopt this multi-cloud approach, DRL is going to become even more essential for managing that complexity.
Wow, this is all really fascinating stuff. We've learned so much about how DRL is being used to optimize cloud computing.
Yeah, it's a really exciting field with a lot of potential.
So to wrap things up for our listener, what's the key takeaway you want them to remember from this deep dive?
I think the main takeaway is that DRL is not just some futuristic technology. It's actually being used right now to make a real difference in the cloud.
And it's only going to get more powerful and more important in the years to come.
Definitely. And I'd encourage anyone who's interested to learn more to check out the research paper we've been talking about.
Yeah, it's full of really interesting insights and examples.
Absolutely. And for those who are really eager to dive deep, there are tons of other resources available online, and new research is being published all the time.
Great. Well, this has been an incredible deep dive. Thank you so much for sharing your expertise with us.
It'd be my pleasure. And thanks for having me.
And to our listeners, thank you for joining us on this journey into the world of deep reinforcement learning and cloud computing. We hope you found it as fascinating as we did. Until next time, keep exploring.